In this tutorial, we are going to talk about differentiation. So what is differentiation? Differentiation is all about finding the rate of change of one quantity compared to another. So it means we can have two quantities and one quantity is changing compared to another. For example, the rate of change of velocity. That's an example of differentiation. To find acceleration, so we'll be differentiating velocity. So we have a lot of notations for differentiation. It can be denoted as f prime of x. It can be denoted as dy dx. Differentiation can also be denoted as d any letter x, dg dx or df dx, or d dx of let's say f prime of x. So these are some of the notations that are used in differentiation. So let's look at the basic the basic differentiation. So let's say we have y equals to a, where a is any number or a constant. Let's differentiate this. So this implies that dy dx is equals to ax. The x is invisible because it's to the power of 0. You know, any number that is raised to 0 is 1. So differentiating, we bring down the 0 and it becomes the coefficient, and we have our constant a, and now the new power, we just subtract 1 from the power, so this becomes 0 because any number multiplied by 0 is 0. And let's say we have y equal to x. Whenever we differentiate x, we get 1. You should always know this. Whenever we differentiate x, we get 1. So we can summarize this and say that if y is equal to xn, then dy dx or f prime of x is equal to, you bring down the power n, it becomes the coefficient, and you subtract 1 from the power. So let's move on and look at an example. So let's say we are given a function of x, and this is equal to let's just say x5. So let's differentiate that function to find the first derivative. So in this case, we are going to use the notation f prime of x to represent the derivative. In our previous chapter, we recognized that if we differentiate x to the power of n, we bring down the power and we subtract 1 from the power. So here we are just going to bring down the power 5, and we subtract 1 from the power. So this becomes 5 x to the power of 4. So let's say we have another example. Y, say this equal to x to the power of 4 minus 3x squared plus 3. What is dy dx? So this is the rate of change. We are differentiating y with respect to x. Y is a function of x, so we are differentiating that function. So we are just going to do the same. We are going to bring down the power 4, and we subtract 1 from the power, minus, here we have 3, you bring down that 2, it comes here, it multiplies, and we subtract 1 from the power, which is 2. And whenever we differentiate a constant, we get 0. So whenever we differentiate 3, we are going to get 0. And dy dx, this is going to be 4 x to the power of 4 minus 1, that's 3, minus 3 by 2, that's 6, x 2 minus 1, that's 1. So that's our answer there. So let's look at another example. Let's say we have y equal to 1 over x minus square root x. So let's rewrite this equation. It means y is equal 1 over x, we can write this as x to the power of minus 1 minus square root of x. This is x to the power of half. So let's go ahead and differentiate that. As we said before, we are just going to bring down the power and subtract 1 from the powers. So half minus 1. So dy dx equal to negative x minus 1, that's minus 2, minus half x. Half minus 1, let me just punch that in my calculator. That's negative half. So here we are going to have negative half. So you can leave your answer like that, or you can write it in this form. F prime of x is just the same as saying dy dx. So this is negative, we can say negative 1 over x squared minus 1 over 2 square root x, because x to the power of negative half, this is 1 over root x. So you can write it in this form.